Okay, example 4. The system of linear equations is the following. 2x minus y equals 1. Okay, equation 1, equation 2. If we add these vertically right now, one of our variables, or more than one of our variables, is going to be eliminated. And the answer is no, right? If we add them up, we get 6x minus 3y equals 3. So again, nothing wrong with this. It just doesn't help. We still have an x and we still have a y. So we need to figure out what we're going to eliminate. And again, it doesn't matter which one you eliminate. Do you want to eliminate the x's, right? If you do, then, this is a 4, so you probably want this to be a negative 4. And you can do that. You can make that happen by multiplying by negative 2. If you want the y's to eliminate, then you probably want to multiply, right? This is negative 2. The opposite is plus 2. So you probably want to multiply it by negative and a 2. Again, I will just pick one. So I will pick, I want to eliminate y. So I'm going to multiply negative 2 to both sides of the equation. Now, the first one, right, haven't done anything to it, so I just write it out. And now I'm just going to distribute, right? So I get negative 4x, right? Now here again, a negative times a negative is a positive, and in this case 2y. So again, negative times negative is positive, equals negative 2. Now, if I try to add the equations vertically, what do I get? Did I eliminate my my y's like I wanted to? That was the goal. And I did, right? These guys are opposites. I get 0y, or just 0. But at the same time, again, I eliminated these guys. Let me make this in blue, right? Because that was our initially our goal, to eliminate y, but we happened to eliminate x. So this whole side is 0, equals 2 minus 2 is 0. Well, that's definitely a true statement. So here, these are actually the same line. If you graph them, equation 2 is really in disguise, right? It's really the same thing as equation 1. If you multiply this second equation by a negative 1, you get the same, you get equation 1 if you multiply negative 1 times equation 2. So here you get a true statement, thus there are infinitely many solutions, right? The lines are the same, so they lie on top of each other, so they intersect at every single point. And here you don't need to check because everything works, right? You only check when there's one solution. So this is what example was this? Example 4, so hopefully that helps. Again, make sure you write these down so you can get your 10 points for notes, because again, it's 0 or 10, and you really don't want a 0 because this is an easy 10 points. Okay, I think this is the last example. Yeah, that's the last example.